Hi, good day everyone. Today I'm going to present a demonstration from my project 1, presentation part 2. This is for the video for the demonstration about my project. My project title will be development of IoT based monitoring system for chicken farming using the Raspberry Pi device. Let me see. So this is the Raspberry Pi device that I connected remotely from my computer, my laptop. So this is how is the OS, the operating system, how it look like, and has been programmed with the temperature and humidity reading based on the flowchart that I mentioned earlier in the slide, which is this one, right? So I will talk about the functionality for this prototype that I have built for function of reading temperature and humidity and what it will does to the value that they have get and obtain. So let's first check on run on the coding or the system that I have built for this product to check the temperature. So basically this code is to just check the temperature of the device. So I think there is an issue with the wiring. Let me double check here. So yeah, there is. So at the moment is a temperature of 34 Celsius and humidity about 66.3, and it will recheck every 3 seconds. So you can see here. So let's stop this one. I will show you the exact one based on the flow chart of this flow chart, which is this rule, this value. Run this code. All right, I'm running this one. So what it does is that it will check the current temperature. It's actually is 34, and there is the equal and greater than 33 is really hot for the chicken. So that is why it should turn on the fan. So as you can see here, the fan pin out or the output will become 0, which means it will be turned on. It will falls under this situation. Or if it's in the graph, in the flow chart, the fan is turned on if it's too hot, it's more than 30. But right now, for demonstration part, I will just set is to 33 because I want to demonstrate if, let's say, what happen if, let's say, I blow off and try to cool down the temperature in this room.
This is my prototype. All right. Okay, so as you can see, this is Raspberry Pi version 3 model B plus, and it's connected to the power for 5 voltage. So do you want this one can be a mobile device if we have the power supply of 5 volt like from power bank or the battery for the mobility purpose. So we'll apply that in the finalize of the prototype, or which the actual product will be for this project. So this one is a sensor of a light sensor. You can see this one. If let's say I turn off or cover it up to have not to detect the light, it will turn off. See, off and off. So this one is for the camera. So I will show you in a while how it work. I will access it from my phone because it is a IoT project. So this one is sensor for the gas sensor. For this MQ135, the gas sensor, to check the quality sensor of it. But in this phase of demonstration, uh, it it is functioning, but the thing is there's no, the system still not have in there yet to like have the specific action on it. Right now it's just capturing the data, but as I mentioned earlier, this is prototype, and yep, this function will be implemented in the next enhanced version of it before it able we finalize or create the actual product. So this is just prototype. The second one is the MQ2 for the smoke gas detector. So it will detect the smoke. If there is a smoke, then what we plan here is to have the fan to turn on and make it the air in the chicken coop to much more clearer and clean. Okay, so the next sensor, which is most important right now, I want to demonstrate is the DHT22, which is this is the humidity and temperature sensor. So this is the humidity and temperature sensor. So all is connected to the Raspberry Pi, and right now I'm remoting this Raspberry Pi from my laptop. As you can see, this USB, you can plug in any USB device to it. So at the moment it's connected to my wireless keyboard, so for the programming purpose, but I will not show you in that. So let me give you a close look. This now is 34.29. Now it's 34.29, which is still more than 33, equal and more than 33 degree. So what I will do is I will try to blow it off, or try to cool down the temperature inside this room. Say we keep blowing off the fan by using the fan. That's just the concept here. We don't have the actual fan here connected to it, because it's just prototype again, and I do have the existing fan here, but I do not have the relay on it. So that's why, as you can see, it's only two cable here, the negative and positive. Should have another one to connect to the GPIO, or the output of the signal, to have like work as a switch, whether it's turned on or turn off. As you can see, 32.29. So actually that's the actual reading, that below than 33, it will be considered as cool for chicken. So the fan will turn off, and the bulb is on, because to start heating the chicken coop. That's how it is work. So right now it's dropping now because I keep blowing. It's now 32.79, and if you notice, humidity is still there, 68, and it will change based on the condition of the humidity of the environment. As of now, it doesn't meet any requirement here. As you can see in the coding here, is it captures 70 to 60, so it's referring to the same image of the flowchart, which is over here. Humidity below than 60, what it will does, humidity more than 70, what it does, and as you can see is 60 to 70, so it's like 60 to 70 percent at that value will have nothing action on the humidity part. For the input that we receive from the humidity data of between data 60 to 70 will have no action on, or no action on the fan or bulb changes on here. So the next moving forward we'll do for the read air quality, right? So, okay, right now I will show you quick one to access the prototype, my project prototype from my smartphone, as you can see. So I have installed this application from the Play Store, and I can access this device, Raspberry Pi, and I have the connection there and access to it. If the device is up and running, I can access remotely from anywhere, as long as I have the network. And here is the list of the capability that you can do from your smartphone. So let's say, for example, you want to see the current temperature in the chicken coop, can go to this here, and it will provide. Right now is the humidity is 64.5, and it will change over the time, each of the second, and the temperature is 34.3. as you can see, it changes every second. So next one is the camera. So let's say I want to look at the chicken coop, what happened to the chicken. I want to monitor from my device, I can do it. So as you can see, I'm looking at my camera of the device, and then if let's say I want to capture, I can just capture from here, from my smartphone. Current image is already captured, then save it. That's how you do it. Then that you can view the CPU and all other things, but the most important part, if let's say you want to restart the device, you can restart remotely from your smartphone. Here, click reboot device and click continue. So as you can see, it's blinking, and then it will restart the device. So that's it for today. That's the full demonstration. So here it is, the demonstration of my prototype. Thanks everyone for watching till the end. Thank you. Bye.